Okay, are we on? All right, now, so what we're going to do is, what we're going to do here and now, how am I doing? Am I on?
Yeah.
Okay, now, what we're going to do is we're going to do some practice problems where you're going to need paper and pencil, and there's a procedure that you're going to go through, a very simple procedure, and actually the procedure is outlined in that PowerPoint, correct? Okay, so I am taking suggestions on the ones that, on the practice that you're going to actually be making the molecules for. What are some of them? Give me some suggestions. Remember, I have the veto power because there's certain ones I don't want to do because I want you to discover certain things. Anybody? No? No? Do you know what I'm talking about? Armindo, you're not open to the PowerPoint, so you wouldn't know. Where's your computer? Okay. Anybody? No? Shall I pick some? Okay. Let's do CCl4. That's a pretty basic one. Okay? Pretty basic. All right? So, what you do is you draw what I call, maybe it's from my generation, the ball and stick model. I'm being metaphorical, okay? So I say, that needs 4 bonds and that only needs 1. So obviously the central atom is going to be the what? The carbon. Okay, so carbon. So 4 bonds, right? At least. Yes? Okay. Then what you do is you've got to count the total valence. First thing you do. So, we know that carbon is from group 14, right? How many valence, how many S&P electrons does carbon have? Remember, the valence electrons are the S&Ps, right? So how many valence electrons does carbon have? S and Ps. Guys? 4, thank you. So 4. And chlorine. Each chlorine has how many? 7, good. So that's 28, 32. Yes? That's the total valence. Total valence. Is that on? Can you see that? Is that on?
No.
No, it's not on? Let's see. All right. So what we'll do is we'll simply go like this. Perfect. Now it's on. Okay, total valence. Okay? Now we're going to subtract from it. When we use an electron, we're going to subtract from the total. All right? Now, these dashes mean what? What do those dashes mean? Bonded electrons, right? How many electrons are in each dash? 2. So 2, 4, 6, 8. Minus 8. What's 32 minus 8?
32 minus 8 is 24.
Z-Man, you had to think about that? Okay. 24, right? Now, how many electrons must each chlorine have when you're finished? 8, yes. It's got to be like argon, right?
Yes.
So, this is a rule. Rule. Each outer outlying atom has to have a complete octet. It has to have 8 electrons. Unless it's hydrogen, then it's going to have 2, correct? Yes. All right? Easy? So, how many additional electrons am I going to put around each chlorine? No. Where do you get 1 from? Who said 1? Yes, but that's not what I asked you. Yes, that's correct. That's correct. Your logic is flawless. But that's not what I asked you. What you said was, how many additional electrons does chlorine need in order to have the number of electrons that argon has? And the answer is 1. That's not what I asked. Maybe I wasn't being clear. What I asked you was, Right now, chlorine has 2 electrons, these two, right? Remember, a covalent bond, they share. These 2 electrons belong to carbon, they also belong to chlorine, right? We also said that chlorine needs 8 electrons. So if it has 2 and it needs 8, how many additional electrons does each chlorine need? Everyone. 6. Okay, so you can put 6. We're going to take our time and we're going to do this because we're going to do it right. Okay, there's 6, correct? Okay. What are these structures called with the dots around them? Do you remember? Did you do your reading? Remember, anybody that does your outlines early, or you can have extra credit. Remember, they're due in 3 weeks, but if you do them really soon, then you get a lot of extra credit, right? Correct? Okay. What do we got? How many did I put around? 6. So I put 6. I spend all that time putting 6 electrons around all 4 chlorines. Is that right? Ginny is saying yes. Yes, that's absolutely correct. So I only put 6 electrons around all these chlorines. Yes? Or did I put 24 electrons around all those 4 chlorines? Shall we count them? 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, okay? 13, 14, 15, 16, 17, 18, okay? 19, 20, 21, 22, 23, 24. Does 24 equal 6? Stunned, everybody's stunned, okay? How many electrons did I just draw around the 4 chlorines? 24, thank you. 24. Now, does the central atom have any excess electrons? Does it have any non-bonded, did it just go off?
No.
How many, does carbon have any unbonded pairs of electrons around it? No. So what's the shape going to be? It's going to be four bonded pairs and 0 non-bonded pairs. Look at your chart. What's the shape? What's the shape? This is a very quiet class. Very quiet. So can we maybe be a little crazy? Yeah. This is what I have. This is Z-Man's going like this. What's the shape? And he's drawing like this. I'm not sure what that means. I mean, I'm in trouble. Okay, I just want you to know that I'm in big trouble. Okay. I don't know what he's doing. What's the shape? He's going like this. I don't know what that means. Okay. You see why I'm a little bit, a little crazy here? Okay. Yes. What's the shape? Alex, I know that you're just recovering from cardiac surgery and you don't want to go crazy, right? You want to be nice and calm. Can you maybe help us out here? What's the shape? 4 bonded pairs, 0 unbonded pairs. What is it? And that comes from somebody from Angola who doesn't speak English really well. Thank you very much for participating, Armindo. I mean, it means a lot to me. I like that. Well done. Okay? Excellent. Excellent. Okay. So, you get it? Now, what I'm going to do is, I'm going to show you an example of that, which is where? It's here somewhere. Where did I put it? Where? Is what? She's saying it's right there. Oh, thank you. You saw that from there? Alex, you are amazing. Excellent. You saw that from there. Okay. So this is tetrahedral. So what you would do is, you would say that this is it. So you'd have to make the shape, with the other atoms on here. Correct? Yes? Right? then you'd come up and show me, and I would say, check, that's correct. Okay, yes, okay. All right, there we are. Tetrahedral. Yes? Yes? Correct? Yes? Okay. So, shall we do one more, and then I'll let you read through this? Okay, let's do another one. Let's do, what is it? SO3. No, I don't want to do SO3. Because that's like there's a double bond in there. Let's do PCl5. PCl5. Okay? Is that all right? Okay. P, Cl, 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 Cl. Right? Okay. What's the total valence? 5, and then 5 times 7 is 35, 40. You need even numbers. Have you figured that out yet? Unless you have a charge. Okay, now, so what would that be? How many do I subtract off? 5 bonds. How many total electrons? Oh, is it past time? All right, we'll finish quickly. So that's going to be what? Minus 10, so that's going to be 30. 6 additional for each, right? Minus 30, 0. So it's going to look like, just give me a second, it's going to look like, where is it? Here? No. Where is it? Here. Okay, no. Wait, oh. You see it? Where is it? This is it, this is it, this is it. So it's going to look like this. See that? 5 equal bonds. So what's the name of that? Trigonal bipyramid. Yes?
Yeah.
See you later.
Bye.
Bye, guys.